Welcome back to Inquisitive Kids. In this video, we are going to be looking at computation of summation notation. Summation notation is a way to represent the sum of a series. It's often seen with the sigma letter here. It's a Greek letter. Let's just look at the basic structure of summation notation. All it's saying is this part represents the sum of all of these terms, where k is the changing factor in each term, so each term is in the form of a sub k. As k is 1, the first term is 1. If k is 2, the next term is 2. So k in this case starts at 1 and goes up by 1. And n is the ending value for k. So on the bottom, you'll see the starting value, and on the top, you'll see the ending value. So in the end, this just means the sum of all of these terms. So now let's take a look at some special formulas. When calculating summation notation, here are some formulas that you might want to remember. If you are finding the summation of all k, where k is starting at 1 and goes up to n, that's just basically saying k plus 2 plus 3 plus 4 all the way up to n. So this is equal to this part as well if you write it out. So if you know about sequence and series, you know that this is a formula to find the sum of an arithmetic sequence. Now if you were finding the summation of all k squared, that would be 1 squared plus 2 squared plus 3 squared plus 4 squared and so on. Then this is the formula to use. We'll be posting another video shortly on why that is the case and how to use mathematical induction to prove that. If you had k cubed, 1 cubed plus 2 cubed plus 3 cubed, all the way up to n cubed, you would use this formula. And finally, if you were finding the value for all terms where each term is k times k plus 1, starting at k, you would use this formula. This would be 1 times 2 plus 2 times 3, so on, all the way until we have n minus n times n plus n times n plus 1. So these are all the special formulas you need to know and eventually remember if you want to get good at calculating summation notation. They really come in handy. Those are some special formulas, but what are the properties? If you're trying to find the sum of all c, but in this case, c is a constant. For example, if I was trying to find k starts at 1 up to, say, 5, and the constant is 2. Well, what does this equal? Let's write it out. This would just mean 2 plus 2 plus 2 plus 2 plus 2. This is A1, A2, A3, A4, A5, and k goes up to 5. So the starting value for k is 1, and the ending value for k is 5. But no matter what, the term that we're adding is always 2. So in this case, if you're finding the sum of a number of constants, all you have to do is multiply the constant with n. So in that case, we had 2 times 5, which is equal to 10, right? So if you had this for any other n or c, then this would be equal to the ending value of k, or the total number of terms, times c. Remember, the one thing is that in all of these cases, k is equal to 1. So if you had k is equal to, say, -4 or +3, that would not work. However, it is really easy to convert from k is equal to, say, -4 and have a way to convert it into k is equal to 1. We'll talk more on that later. Now, the next property is the distributive property. If you have this expression here, and you're trying to find the sum of all c times ak, where c is a constant, all you have to do is factor out the constant. So it's not exactly the distributive property, but almost like it. You can factor out the constant. So you have c times, and then find the value of here. And the final property would be if you were trying to find the sum of all ak plus or minus bk, so two terms being added or subtracted, you could first find the sum of all ak and then the sum of all bk, and then add and subtract those sums. However, this does not work for multiplication or division. So for example, if you had 2k plus 4 times 3k plus, say, 6, this would not work, and you can't split it apart. Whenever you are dealing with multiplication or division like this, you always have to simplify first. So for multiplication and division, you have to simplify before sigma. So basically, all this means is saying you can't directly apply the summation notation on an expression like this. You have to multiply it out and get 6k squared, so on. That way, after you turn it into the addition of multiple terms, that's when you can use all the properties and the formulas we already talked about. So the best way to learn is to see some examples. Here is the first example. Pause the video to see if you can try to use the previous formulas or properties to help you solve. Alright, so here's the first problem. Convert into summation notation. 3a plus 4a plus 5a all the way up to 2016a. Well, this is just a basic problem that tests our concept. We first write summation notation. So as you can see, in each term, a stays the same, but it's the coefficient of a that changes. And lucky for us, it changes by moving up 1 each time. So this is equal to Ka. Each term can be represented as Ka, where K is the one that's changing. K's starting value is 3, and it goes up to 2018. So this would be how we write it in summation notation. Now let's try this one. Solve for the sum of all 3k minus 1, where k starts at 2 and ends at 4. Well, in this case, we would have 3 terms. The first one is 3k, but k is replaced by 2 minus 1. That's the first term. Plus 3 times 3, this time k is equal to 3 minus 1. Plus 3 times 4 minus 1. And this is the ending value of k, this is the starting value of k. All we have to do now is simplify. 6 minus 1 plus 9 minus 1 plus 12 minus 1. That is equal to 27 minus 3, which is equal to 24. So the sum of all 3k minus 1, where k starts at 2 and goes to 4, would have a value of 24. Let's use the properties we learned previously and apply them to number 3. If the sum of all ak, where k is 1 to 10, is equal to 65, and the sum of all bk, where k is starting at 1 and ends at 10, is equal to 32, then find the value of this expression. We see that this expression is a trinomial with 3 terms being added together. So let's split them apart. This is the same as the sum of all 2ak plus the sum of all negative 3bk plus the sum of all 5. And what's the next step here? Well, we see that in these 2 terms here, there is a constant being multiplied to the variable part. So what we have to do is factor the constant part out. This gives us 2 times the sum of all ak, where k starts at 1 and ends at 10, minus 3 times the sum of all bk, where k starts at 1 and ends at 10. And finally, here we have the summation of all 5. Well, think about it. 5 is a constant. This would just be adding 10 5s altogether. So this part would be 5 times 10, giving us 50. Now, what's the next step? Well, as you can see, these 2 parentheses parts was given in the problem. We know that this part is equal to 65 and this part is equal to 32. all we have to do now is substitute. 2 times 65 minus 3 times 32 plus 50. This is 130 minus 96 plus 50. 180 minus 96. So finally, in the end, our answer is 84. Solve the sum of all 2k minus 1 times 3k plus 1. If we see two expressions being multiplied together, we first have to use the distributive property to multiply it out so that we have it in the form of a polynomial with multiple terms. So this would be equal to 6k squared minus 3k plus 2k minus 1. Or we could rewrite it as 6k squared minus k minus 1. Now the same thing as previously. If we see it in the form of a polynomial with multiple terms being added together, we can simply separate the terms. So the first part would be 6 times, remember we're factoring out the 6 because it's a constant, k is equal to 1 to n, and the sum of all k squared, minus the same thing for the second term, minus the sum of all 1, where k is equal to 1, it ends at n. Now let's move up here. What's the next step? Let's go turn by turn. The first part would be 6 times, and this expression we can actually use one of the formulas above. So the formula for the sum of all k squared would be n times n plus 1 times 2n plus 1 over 6. The second term would be minus, and there is also another formula for the sum of all k. So the formula for this would be n times n plus 1 over 2. And finally, 1 is a constant, so we just subtract 1 times n, or n. And at this point, all we have to do is simplify. And yes, it will be in terms of n. So this 2 6's cross out, and we'll have n squared plus n times 2n plus 1 minus n squared over 2 minus n over 2 minus n. Now we continue. 2n cubed plus n squared plus 2n squared plus n minus n squared over 2 minus n over 2 minus n. Let's combine like terms. The 2 plus n and minus n cancels out, and we're left with 2n cubed plus 2n cubed, and then we have 3n squared minus 1/2 of n squared, which is equal to 5 halves n squared minus n over 2. So in the end, this expression is our final answer. Now let's look at the final problem. Find 1 times 4 plus 2 times 7 plus 3 times 10 all the way up to 30 times 91. Here we have to first rewrite it in the form of summation notation. So here we have the sigma symbol, and let's start k is equal to 1. Now, what is each term that's being added together composed of? Well, each term, so think 1 times 4 or 2 times 7, it's two numbers being multiplied together. And what is the relation of these two numbers compared to k? Well, when k is equal to 1, it's 1 times 4. When k is equal to 2, it's 2 times 7. When k is equal to 3, it's 3 times 10. So the first number is always going to be k. It's k times something else. And now let's look at the separate pattern for the other number, for the second number. 4, 7, 10. So it's an arithmetic sequence adding 3 to each subsequent term. So to write a formula for this sequence in terms of k would be 1 plus 3k. And how long does this go for? Well, the starting value for k is 1, and the ending value would be 30. So this is how we would write this expression in summation notation. Now, the first step to solving this expression is to first multiply out whatever we're trying to find the sum of. So this is equal to k k is equal to 1 to 30, and the inside is going to look like 3k squared plus k. Now we can take apart these two terms. So we have 3 times 1 to 30, k squared, plus 1 to 30, the sum of all k. And we'll use the formula n times n plus 1 times 2n plus 1 over 6, plus n times n plus 1 over 2. But in this case, what is n? In both of these cases, n is equal to 30. So we'll rewrite this as 30 times 31 times 61. And we'll rewrite this part as 30 times 31. Now let's simplify. Well, this cancels out, and we'll have 15 times 31 times 61 plus 15 times 31, which is 15 times 31 times 62. In the end, the answer is 28,830. So 28,830 is the sum of all of these terms. So this is the final answer.